Hey guys, welcome to this new series on Halide. So this is going to be fun because I'm making a series about something that I'm currently learning, and I've never used something like this. So this will be a fun learning experience for me, and I hope for you as well. So this is also something pretty different from what I have previously done. Most of my work has been involved in Python. All the videos that I've made are in Python or MATLAB. So now we'll take a generational leap and move to a C++ library. So basically, Halide is, I'm just going to read it from here, is a language for fast portable computation on images and tensors. So Halide is kind of like it's embedded in C++, so it's kind of like a library for C++ where which makes doing digital image processing and anything related to tensors and that kind of stuff pretty quick. So something like convolution and any image processing algorithm, image or tensor processing algorithm rather, you can do it in Halide. And the key idea or the key reason why we are dealing with Halide or why Halide has become popular in recent times is the fact that it separates out the schedule and the algorithm. So let me give you a quick um, overview of like why that's important. So there was a there was a fantastic talk at CPPCon 2020 about why Halide is awesome, and let me show you something first. Um, let's see. Hopefully, I can come to it pretty quickly.
Plain C++. When it was written in 20 across different.
All right, so this is where I want to be. Let me cancel that out. And okay, so this is just the code to blur an image. Basically, perform horizontal and vertical blur. And the fact is, now that should be a bunch of for loops. So the algorithm for blur is pretty simple. You take the surrounding pixels and then you average them out. So the algorithm is pretty simple. But this you see there is a lot of scheduling that is being applied, tiling and scheduling, which is very architecture specific. So it makes it harder to maintain codes like this, and it makes it cumbersome to write code like this. I don't think I can ever come up with this optimized code. So what Halide does is it separates out the algorithm. So you can just work on the algorithm separately, and then you can work on the scheduling or optimizing the algorithm for the specific hardware. So since these two things are separated out, it makes it easier to manage the code. Here, it's all mixed. So managing the code is harder. So that's the key advantage of
With a mess that looks like this program.
using Halide. And I urge you to check this out, the CPPCon video. Now, okay, so here, like this is the algorithm bit, like they show how to take blur, and it is done in a fantastically simple way. So this is just the algorithm, and then you can worry about scheduling it or optimizing it separately, independent from the algorithm. So that's good. Why am I making a video on Halide? Unfortunately, there is no book available about Halide stuff, and the resources are quite limited. Even though this language is used by Photoshop, by Adobe, by Google, the resources available about it are pretty shallow or very less. So basically, you have to try a bunch of things yourself and see how it goes. So hopefully, my series will fill that particular gap um, when it comes to resources. The only two videos that I found online are the CPPCon talk, and also there's a CVPR tutorial, but that's from 5 years ago. Um, the other available resources are basically there's a bunch of tutorials on Halide's webpage. So these are the ones that we will be going over. Um, and then I'll mix and match, like I'll go over some of them. I'll do some other stuff as well. So let's see how it goes. So let's get back. Um, typically when I do C++ stuff, I love to code in Linux and use G++. But for this video, because I want to get my hands wet in Windows development, we will use Visual Studio. So I'm not too familiar with Visual Studio. I typically use VS Code. So it'll be a learning experience for me as well. And we'll see where we get. So in this first video, I'll just show you how to set up Halide for Windows. So one thing that you need to do is, first of all, you can directly download the Halide binaries. So let's look at that. So when I click on it, the latest version is 13, and you can see there are Windows and Linux binaries. So let me first give a quick word on the Linux binaries. It's very simple to execute the Linux, or rather build in Linux, because all you need to do is download the binaries, and with G++ you provide the library paths like this. So pretty straightforward. All you need is this command, and then you export this variable and basically location of your .so file, and then you're done. But in Windows, we would have to do a couple of things, which is interesting. So I have downloaded the x64 build for Windows, and I've extracted it out. So let me show you what the files are. So when I go, I have extracted this in Tools, Halide. So you will get 4 folders. Your this is the library, and here your SO or .dlls are here. So in Windows it's .dll, in Linux it's .so. The interesting thing, which took me a while to realize, is that the notice the sizes are very different between what's shipped for Windows. So for Windows it's about let me scroll up, it's 45 MBs, and for Linux and other platforms it's 100 MBs. The reason is the debugging symbols aren't shipped for Windows. So you see only the release module is, or the release configuration is shipped. So this DLL, so you wouldn't be able to debug with this. So what you need to do, you would need to build Halide from scratch with the debug configuration as well. So that would generate the debug DLLs, the link libraries for Halide, if you want to debug your Halide code. So what I'm going to do is, I have done that myself. So I can, I'll at some point I'll put in a link for a Google Drive link for the debug DLLs. So I know it's probably not the right thing to do, sharing DLLs like that, because people are apprehensive about DLLs. But I mean, you can use it or you can build it on your own. Now, just a quick word on building Halide. So let me go back to the GitHub README. So if you're on Windows, install VC package. It's a dependency manager, and it's like pip for Python and does everything for you. So all you need to do is type VC pkg, install Halide, and then what target you want. The only issue is that it's going to build LLVM as well, so it's going to take up 200 gigs of space. So that's the only unfortunate thing. But let's see. I think I'll provide some the debug binaries, and let me also show you how it looks like. So when I go back, this is my VC package thing. In packages, I see Halide, and here, when I go to debug, I see my binaries. Okay, so that's good. Okay, with that sorted out, let's build our first Halide code and see, like, basically the point is I won't go through the code, I just want to show you a successful build. So for that, we'll first start Visual Studio. And let me go here and let me create a new project. So, all right, so Visual Studio is open here. Let me also increase its size. Let's see, so that fills my screen. Okay, I go to File, I create a new project. And my project is, I want to create an empty project because I don't want any files associated with it. And let me call it test1. Notice where it's stored. I'll change my directory to C drive halide. Okay, that's pretty much it. And boom, a new project should be created. Great. Now, first, let's place in some code, some halide code. So what I'm going to do is just copy paste the first tutorial and add it here. So I go back, I'll just copy this whole code, and we go back to our Visual Studio. In source, I'll add a new C++ file, and I'm going to copy this whole code. Now, IntelliSense is already telling me that, hey, you don't have halide. I can't find the halide.h files and all those errors. So we won't worry about all of that. So first, let's go to, so first we'll check out the release build. So, okay, even before that, we need to tell Visual Studio, or rather this project, where to find the libraries and the DLLs. So we go to Configuration Manager, and so right now we are on a debug. Let me switch over to release, and then I click on project, and then I go to project properties. So with this open, um, first navigate over to VC++. Also, I should have mentioned I'm using VC 2019, and I think that has C++ 17 and a certain Microsoft C++ compiler version that works with Halide. So probably should stick with ES 2019 and above. Okay, so first of all, I need to provide the include path. So I go here and I add my path. So for Halide, I know where my Halide installation is, and I go to lib and I include that. Then I also need to, so that's my include, and then I need to pass in the path for my library directory. So I go here, I again navigate to the same folder. Where is it? Tools, Halide. Oh no. Um, oh, sorry, I messed up. So this is the library one, and for include, I had to do the include folder. My bad. So I go back, I go to include. Okay, so that's good. I have set these two. Now, Halide requires C++ 17. So we go to C++ and we set the language to be C++ 17. That's good. Now, we need to set path to uh, the Halide library. So I go to linker, and in linker, where is it? Yeah. So I need to provide the dependency on halide.lib. So this is the same thing as when you type -l halide in G++. So this is the same thing as that flag. The other things are the same things as providing the library and the symbols path. All right, so I guess that is pretty much it. Okay, awesome. So we are set with this. Um, Let me bring this up as well. And notice, as soon as we added the library locations, the red squiggly lines disappeared. So what this code does, it loads in Halide, it performs some simple computation, and then it checks that computation and then prints out success. So if our build works successfully, we'll see success printed out in the terminal. So let's build it. And notice we are in the release mode and I messed up. So we need to be in x64 configuration because we have only installed for x64. So I have to do whatever we did all over again because the configurations that I did were for the previous for x86. So I'm gonna pause the recording and I'll set up that configuration and then um, resume recording. So give me a moment. Okay, so I've done all that linking and all the same thing again, and now we are ready to build and run our code. So I'll click on this and I'll see, and our build worked well. So we have issues with linking. So our so this exe couldn't find halide.dll. So we need to attach that. So this library, let me again pull out where it is. So in the binary extracted binary, so in the bin folder in release, there's this halide.dll. So that's what we need to use. So now in VS Studio, Visual Studio, you can tell it where the halide.dll is located, but the easiest way that I typically use that I always put the DLLs where the binaries are created, where the executable is created. So let me copy this DLL and I'm gonna paste it. I know this is not the most efficient way. Um, I can dig around the settings to see how to set it up properly, but then this is just quick and dirty. I go to my project folder and then I go to x64, and since it's the release build, I go here and I paste halide.dll. So that's pretty straightforward. And ooh, let's see, where should I have pasted this? Oh, I think I pasted in the wrong place. So in test one, x64 release, this is where I should paste it. Okay, now let's try it again. Um, hmm, it couldn't find halide.dll. That's so the huh, let me go to project settings. As I said, this is a learning curve for me as well. Um, I guess I probably need to include a reference here. I will put this, and the linker couldn't find halide.dll, which is interesting. So if the linker couldn't find, the build wasn't successful. So um, oh my lord, it had to be halide.lib. It's not the dynamic library. That's why. Okay, my bad. I set it to be halide.lib, and I think we are done now. Okay, so I've been stupid. Now that I run it, it ran successfully, and you can see it printed out success. Phew, that's good. So it worked out fine. So let me again show you the configuration. Okay, that was a pain. So all you need to do is basically set the include path, set the library path, set C++ to be 17, and then also in the additional dependencies set in halide.dll. We'll do all of this again, and you'll see why. But and also don't forget to copy halide.dll, the binary, to the same directory as the executable one. So this is all well and good, and you can play around with this and you'll be fine. But now, what if you wanted to debug your halide code? What if you wanted to run it in debug mode. So let me switch over to debug mode. Now, if you just downloaded the binaries from the official Halide repo, you wouldn't be able to you wouldn't get the debug binaries. So the debugging symbols wouldn't be visible to you, and you wouldn't be able to debug. If you don't care about that, I think you can stop the video now and go on. But basically, right now we will do the same thing. We will set up the project for debugging. So it involves the same files, just that I now have the binaries that from the debug configuration. And I got them by building it from scratch on Windows. In Linux, you don't need to worry about any of that. All you need to do is download the binaries and you're good to go for debugging or anything like that. But here we need to build separate binaries for the debug configuration. And I've done that. So now let's set up the debug configuration. So I again go to project properties. So let me now set some in debug mode, um, set the path. Um, I go to C drive, I go to tools, and this is where I have built my Halide debugging. And oh yeah, and I just give it my include folder. So that's my include directory. And for my library directory, I again go to the same location. So, oh, so here now I'll go into a debug one. So that's sorted. Now, again, let me set my language is C++17, and let's see, my linker is halide.lib. Great, that's it. Um, hmm. It is unable to include halide.h. Let me double check if my halide files are present. Packages. It should have loaded from there. Oh, that's funny. I accidentally changed the release configuration. I need to go to debug and do it all over again. This is not fun, so I'll again pause the recording and do it again. All right, after 10,000 years, I managed to add in all the locations. I am sure there is a quicker way to do this, but since I'm new to Visual Studio, I'm struggling through it, so hopefully you don't mind it too much. So now that we have linked the debug configuration, we can start debugging. Um, the one thing that you need to do is, well, let me show you what the issue will be. So let me set a breakpoint at this location. So at this point, and let's build in debug mode. And as soon as I build it, well, it works fine. So here you can see I have entered I'm at the breakpoint, and you can see that I can see the values of my variables and what they are and everything. So let's continue, and an exception is thrown. And the reason why this exception is thrown, that's something I want to get into, is I think because it the DLL that we have, it's linking against the release one. So we need to supply it the debugging library. So let me stop this. Let me go back to my source. And what I'm going to do is I will copy over my debugging binaries. So I go to debug and I go to binary, and let me copy this over to where my project is. So it's in Halide, test, test1, x64, and now we are in debug mode. So all I need to do is paste it here, and that is enough. That should be good. So let's see. So let me run the debugger again. We are at this breakpoint, and then let me click continue, and another exception is thrown. That's interesting. Let me see why that's true. Oh, yeah. So I figured out the issue. So let me actually um, go back and show you the issue again. So let's build, and the build succeeded, and let me now run it. So this is all an issue with the debug mode. I need to have the debug symbols from the DLLs, and I don't have those, and that's why I get this error. So all I need to do is copy over my DLL. Now, okay, so let's go back and let me go to the location where I downloaded, or rather built my, using VC package, the binaries for the debug. So I copy this, and the location where I'm going to paste it is, that's the incorrect thing that I was doing. I wasn't aware of the data of the directory structure how Visual Studio makes. So this is where my files are stored, and this is where the binaries, excuse me, that are built are stored. So I need to go here, and in debug, I place my Halide DLL. So that contains the debug one. So now when okay, this is not over. I also need to place in another library um, called zlib, and its binaries, its debug binaries as well. So I go in and I copy its DLL. So I guess there's some kind of dependency, and I think that's it. Now let me stop this, and now let me build again. So okay, I've reached my breakpoint, and I keep on continuing, and hopefully this works. All right, I guess it's loading in all the symbols, and success. All right, so we finally were able to debug our Halide code. I know this is just a one-time pain. You can create a template out of this solution, and then so that you don't have to set up this library configuration again, or you can keep on modifying the file here and keep on playing around with the Halide code. So let me review some things. The couple of important things that you need to do is you need to specify the include directory, you need to specify the library directory, and you need to set C++ to be C++17, and also add halide.lib in your dependency. Once you have that, you will be able to successfully build your Halide code in both release and debug mode. Now to actually run it, you will need access to the Halide DLLs, and those, so for release mode, you can find halide.dll directly from the GitHub binaries. So you can just download them. The binaries are available on Halide's webpage or GitHub webpage. But for debugging, you'll need to build Halide from scratch to generate the debugging symbols. So again, I will hopefully for x64 I will put them on Google Cloud and share the link with this video at some point. And that's one thing. And for Linux, you don't have to do anything. The Linux binaries are shipped in debug configuration, so you don't need to worry about any of this. So all's good in the Linux world. So hopefully this long video for setting up Halide was sufficient. I know I went into a lot of details, and there were learning pains for me as well because, again, not too familiar with Visual Studio, but hopefully it won't be this painful from next video onwards. Thanks for watching, and I'll see you next time.